So we start recording. Welcome guys to our course ECE 9013A, which is a programming for engineers. Our course will be using Python programming languages, and it's an introductory course for the programming. First of all, I will share a take care message from the university or from Western Engineering that should be shared. It is applied for in-person classes. However, our course is fully online course. So I'll share my screen right now. So this slide shows that both vaccine and mask are mandate for in-person classes or to attend at the university in person. Each student should complete in a daily basis their symptom checklist every day. So student who found on campus and he did not do that, he should be referred for investigation under the student code of conduct. So please make sure, as I announced in the first announcement of this course, that the preserved classroom for us would be empty during this time for those students who cannot attend or attend the class from their homeroom or from anywhere. So they have the time to be at the classroom and attend the class from there. Also, if needed, some activities could be conducted with the attendance of the TA. Our TA is available in London for in-person or via Zoom meeting. So if we need the TA to attend certain event or something like an exam, if required by the university, so our classroom is preserved for us, and you can be in person during the class time, every Monday, 6:30 to 9:30 p.m. Okay, so let's back to our course outline. I will start with our course outlines. Okay, so our course code is 9013, Programming for Engineers. As a description or a general description of the course, Programming for Engineer is intended for MEng student with a little programming experience. So we are trying to give you an introductory course to improve your programming skills. So we'll give you the basic understanding of the communication, of the computation, and how it's play a vital role nowadays in many disciplines. The enrollment restriction, this course is restricted for non-software engineering student. So it's restricted for M-Engine communication and signal processing, M-Engine power system, and M-Engine robotics and control. Or if the student has a certain exception from the department chair or from the graduate chair. I am Muhammad Noor Injadat. I hold a PhD from Western University back in July 2020. I also hold a Master of Engineering from the Western University in 2015. And also I hold a master degree in a computer science back in 2002 from University Putra, Malaysia, in Malaysia, and a bachelor degree in computer science from Al Bayt University back in 2000 in Jordan. Our course format will be online course, remote learning, full remote learning course. So our course will navigate as an introductory programming course with different topics and different units. I divide it by topic number and week number. So topic 1 is week 1, topic 2 and week 2, and so on. So in week 1, we will know what do we mean by computation, how we declare and use variables in different types in Python, apply some basic mathematical operations. And in week two, we will discuss some iterations, conditional statement using loops. In week 3, we'll go to string manipulation. And in week 4, we do decomposition, abstraction. What do we mean by programming functions? In week 5, we'll use the tuple list, some kind of list, and as a data structure. Then we will have in week 5 Thanksgiving holiday, which means no class. It's coming on Monday. Then in unit 6, we'll do the recursion, dictionaries, and some other techniques in Python. Then in week 7, we'll do the testing, debugging, exception assertion. Then the reading week will come in week 8. In week 9, object-oriented programming. What do we mean by object-oriented programming as a concept? How we will use it in Python? We'll use some classes and inheritance, which are the basic concepts of object-oriented programming. And if you see here OOP, which means object-oriented programming. Then we'll learn some kind of data structure and algorithms like sorting, searching algorithms, and we will be done with the last unit, which talk about the complexity. Week 12 and 13, those are dedicated for final project presentation. For final project presentation, you will receive the instruction for final project presentation, how we will form the groups next week. I want to make sure that all student added drop period are done, so we have a final list of the course. Then we can introduce the topics of the project, and I will talk about the group project, so you can start from today to form your group project from 4 to 5 students. Now, with the specific learning outcomes, with depth and the breadth of knowledge, 30% of the course weight or your final grade mark will be toward this point. Then the research and the scholarship, it will be 10%. You'll learn some research skills. Application of knowledge, how you will apply the knowledge you gained, 25%. Professional capacity for 15% of the course weight. And communication skills and awareness of limits of knowledge. And this will form 100%, which is the total course grade final mark. Assessments. We have 3 homeworks or 3 assignments. Those are individual tasks. You have to do it by your own, and it will cover topics from 1 to 9 from your course outlines. These are approximate dates, but normally I tried my best to stick with it. So October 10th, 2021 will be the due date of assignment 1, which is almost a month from now. October 31st, assignment 2, and November 21st, which is assignment 3. Each assignment will worth 10% of your total course grade. Now, midterm test, we have a midterm test. It is after reading week. Topics from 1 to 7 would be included in the midterm exam. And this exam is worth 20%. It would be multiple choices, true or false, or it could be all of those or part of it, and some like short answer the questions, and one question that you need to write a code, find an error of the code, find the output, what this code will be, or the output of this code. We have 2 quizzes. The first quiz will cover topic 1, 2, and 3, and the second quiz will cover topic 8 to 11, which is literally that within the midterm, quiz 1, 2, we are covering the total 11 topics that will be discussed within this course. So quiz 1, almost a month from now, which will be October 4th, and quiz 2 will be in November 22nd. And by the way, the quiz is 20 minutes. I know some students applied for accommodation that they require more time. I will put in my consideration that the quiz timing, I'll put it 30 minutes. However, it's required as maximum 10 to 12 minutes. So I'm giving almost a triple the required time to do your quiz. The project proposal, the project will be divided into 3 parts: project proposal, project report, and the project presentation. The project proposal will be required on October 17th, and we'll talk about this once we introduce the project titles and we finalize the group list. Project report is required December 7th, and the project presentation will be carried on the November 29th and December 6th. You will ask me a question now, or it will come to your mind that there's a question, oh, how I will do my presentation. However, the deadline for the final report is after that date. You will present what you will reach. You have more than enough time, so you should be done by that date. But I'm giving some extra time to finalize your report. I know that sometimes you are busy with other courses, other requirement, final exam, all of these things. That's why I give an extra day to submit your final report. However, during that time, for example, the second group, December 6th, their presentation, and the deadline is December 7th for their report. So they should be done and do a full presentation of their topic. Those who will present in November 29th, if there is a little part is not covered yet in the report, then you don't need to present it. Here, there is an important point, guys. I don't care about attendance. I understand sometimes something coming up and you couldn't attend on time, 6:30 to 9:30, and you can see the YouTube recording. But on November 29th, December 6th, which is the presentation date, all students are required to attend the whole class till we're done with the presentation on that day. For example, your group present in November 29th. I have some experience before with undergrad student. With a grad, I don't experience this, but to be clear from the beginning, that some students, after they are done with their presentation, they left the class. No, it's a kind of, you are respecting your colleagues. They sit and listen to your presentation and attend your presentation. You have to respect them back. So on those 2 dates, November 29th and December 6th, attendance are mandatory on those 2 days. The whole class, the full class, no exceptions. Clear? If you have anything, just send a message in chat. This is an important point, guys, because failing to attend the whole class, this will result in a penalty and a mark deduction in your project grade. And to be honest, some of the students, they join the meeting, leave, and at the end, I will end meeting for all, so they are attending till the last second. You will not know you will know that your presentation is November 29th or December 6th, but how is the order on that day? I will pick randomly. And I might ask students, even if it's not your presentation, you attend the presentation, I can give you a question about that presentation. So I need actual attendance. Say whatever, some of them, oh, how strict he is. No, it's a kind of respect. Once you are presenting, you need everybody to keep attention to your presentation. Myself, I have to keep attention to your presentation, and we have to respect your timing and your efforts in preparing that presentation and in training yourself how to present to your colleagues. So from my point of view, it's a point of respect, gaining knowledge. You will learn something for sure from those presentations. So it's for your benefit. At the end, it's at your benefit, not my benefit. For me, 98%, I know what the student will present. Okay, clear about those 2 days? Okay, so we will have individual task and the group task in this course. What are the individual and what are the group? Activities in which collaboration is permitted, project report, group project. Each group will be minimum of 4 and maximum of 5. Don't come with and tell me, no, I would like to work individual. No. We have almost 60 students in the course. The TA is paid for 5 hours per week. So to mark the reports, she will spend a lot of hours. So we have to be also fair with her. And also to reduce the amount of effort that required if having individual project. So it's a group project. Also, we need to encourage teamwork. So minimum 4, maximum 5. You don't know anybody, those students, at the beginning, I will make an Excel sheet in Google Drive. You write your name, and any student who don't have any group, there is a certain place on that sheet, he or she will write their name, and I will assign or add them to a certain group. Or if all other group are completed, 4 to 5, then I can form some extra groups to accommodate all those individuals. Project presentation, a group presentation, same as the group project, and each member of the group should present. You should have certain slot of your presentation time to present. For some, I experienced before, some groups, they like put 90% of the presentation on X, Y, and Z, they just present 2 minutes, 2 minutes. No, it should be divided equally. And each group member should be able to answer any question raised by me or by students. So, for example, you presented slides 1 to 5, your colleague 6 to 10. Don't tell me that this is his part or her part and this is my part. I will answer my part. No. If I give the question to X, she should or he should answer. Because it's a group project, you should understand everything in that project. Activities in which a student must work alone, collaboration is not permitted. Homework assignment, it should be individual. Midterm test and the quizzes. And guys, I'll mention that in the slide in a few minutes. All this course tasks, since it's remote, for remote learning, the university put some quality measures on those courses that everything will be checked with Turnitin, and for the code question, we will have a similarity or code similarity check. You know that the cheating is an academic offense here at Western and should be reported to the department head or the dean or the graduate chair, and they can decide what to do. So all your work in this course, it's a simple course, easy course. It's not a complicated course. I'm not a complicated guy. Even in marking, I'm very fair with everybody. My TA she will be very fair. I talked to her. She's a very nice PhD student here at Wilson, and she understands exactly what she's doing. So don't worry about marking or to have a hard exam or a hard quizzes. I'll not bring something new from the space. What I'm teaching you, I will ask you about. Now, the other part is your efforts and your follow-up and your study. And I'll repeat it 3 times. Practice, practice, practice. How much you practice using Python, do a different example, play with the code, you will understand more. And for sure, you will get a good mark. So, practice is very important. Your work should be genuine, original, no cheating, no copy and paste. So this should be our deal from the beginning of the course. The required textbook is Gutang John book, Introduction to Computation and Programming Using Python with Application to Understanding Data, which is the MIT Press 2016. Now we have a 2020 version. I have it. So I'll see if there is any new changes. We will mention that. Optional course readings. If I found that the handout and the programming codes or example are not enough, I might add some reading in certain weeks for certain topics. Those would be uploaded as a handwritten notes at the beginning of the class that we will use these handwritten notes. So these will be provided on a weekly basis if needed. Here is the cheating, the code of conduct, the health wellness services, accessible, which is generic Western policy thing, and you should be aware about all of those. So here we'll have week 1. Most of these handouts are taken from the MIT Press handouts, which is the original author handouts, with some changes that we did here at Western. So as a kind of copyright, they are mainly originally the original textbook handouts. Clear, guys? Any questions about the course outlines before starting with the handout? Guys, I don't know who's the student who asked for these subtitles, but you know, it's not accurate 100%. Questions, guys, or shall I move? Okay, we had 52 students, which is great percentage of attendance. We will start with student by student. Introduce yourself, your specialization. I need to break the ice, guys. Keep silent and just listening. Okay. Chunyu Pu, introduce yourself.
Hi everyone. I'm Chen Yu. Can you hear me, guys?
Yeah, we can hear you. Yeah.
Oh, okay. So I'm Signal, and I'm sorry. I just how can I introduce myself? So I need to introduce my stream.
Okay.
Sorry.
Okay. Thank you.
Okay.
Xinjiang Guang. Introduce yourself, please.
Hello, everyone. I'm Zhenjiang Wang, and I'm from China. And I want to say I really like this this course because I have learned a little about the pattern. So that's all.
Okay, thank you. Aisha, please introduce yourself.
Okay, thank you so much, Dr. Mohammed. Yeah, my name is Aisha Dira, and I am a PhD student. So I joined this class because I like to learn programming, and I am waiting for the approval to join the class. Thank you so much, Doctor.
Thank you, Aisha. Yukun Yen, introduce yourself, please.
Hello.
Yeah, we can hear you.
Everyone. My name is Yi Queen. I am the student of the robotics, and I'm graduate from the Carleton University in Ottawa. So nice to meet you guys. Thank you very much.
Thank you. Nice to meet you. Ahmad Jamal.
Yeah. Hi, everyone. My name is Ahmed Akbar. I'm an MN student in power systems engineering, and I'm looking forward to this course because in my undergrad I took C++, so Python is a new language for me in programming. So thank you, Doctor, for having me in your class.
Thank you, Ahmed, and nice to meet you. Guys, also the purpose of this introduction, each one, that's good that you can and Ahmed mention what they are. I'm engine communication, robotics, power system. So it might give some help for you to start communicating with each other and forming your group for a project. Because I would prefer that, look, for example, those in robotics to use Python to apply it in some robotics work. Those in power to have it in power. So you benefit from the course at your specialization and at your research area. Okay, Bilal Osman, go ahead, please.
Hello, Dr. Mohammed Noor. Hello, everyone. My name is Bilal. I took my bachelor degree from the University of Windsor and electrical engineering, and I'm specializing in power systems. Looking forward to work with you guys. Thank you.
Thank you, Bilal. Han, please go ahead. Hello, Han, are you there? Okay. Jinyuan Zhang, go ahead.
Hello, everyone. My name is Jin Yuan. I'm a MN communication student. I complete my undergraduate study at Western University this year. So nice to meet you guys.
Nice to meet you. Thank you. Yuan Fu.
Hello, Professor. And can you hear me?
Yeah, I can hear you.
Yeah. I'm in communication and signal, and I graduated from McMaster. It's my first year in Western. I'm looking forward to the more stuff in Western. Thank you.
Thank you. Thank you, Ian. Umair Muhammad.
Hello, everyone. I'm Umair Muhammad Ikram. I'm born and brought up in Saudi Arabia. Did my bachelor's in India. Now I'm at Western for communication and signal processing. Thank you.
Thank you, Umair. Alvina Ahmed, please go ahead.
Hello, Professor, and hello, everyone. I'm specializing in communication and signal processing. I have previously worked in SQL and Java to learn Python. That's why I've joined this course. And yeah, looking forward to connect with everyone. Thank you.
Thank you, Alvina. Omer, you can mute your mic. Okay. Baiki-san.
Hello everyone, my name is Bai Qi. I'm specializing in communication and signal. Nice to meet you. Thank you.
Okay, how you pronounce your first name? Baishi?
Bai Qi, yeah.
Baichi. Okay. Nice to meet you.
Nice to meet you.
Yeah. Siwan Ma.
Okay, can you hear me?
Yeah.
Okay, my name is Siyuan Ma, and I'm from China. I'm specializing in communication. I have learned the Java and C before, so it is a challenge for me to learn Python, and I'm looking forward to use it and learn it.
Thank you. Thank you. Yu Wang.
Hi, Professor.
Hi.
Can you hear me? Yeah. Hello, everyone. My name is Yu Wang. I'm the student in communication and signal processing program, and I'm graduate from McMaster University. I really enjoy this course. Nice to meet you guys. Thank you.
Thank you, Yu. CG Jang.
Hello, everyone. My name is CG, and I'm from the Engineering Medicine program. And I'm also a student graduate this year from McMaster University. Thank you.
Thank you. Engineering and medicine. Sounds good. Okay. Orva Doshi.
Yeah, hi, I'm Urva Doshi, and I am from Mumbai, India. I have completed my bachelor's in electronics engineering, and right now I'm specializing in power systems. So I have a bit of a background in software, like I've learned C and C++. So looking forward to learn this Python course, Python language. Thank you.
Thank you. Okay, guys, those who introduce themselves, you can mute your mic back. Okay, Kanav Yadav.
Hey, I'm Kan Yadav. I did my undergrad from the University of Waterloo in mechatronics. At Western right now, I'm doing my PN in robotics and control. Looking forward to knowing you all.
Okay, thank you. Yamping Zhu.
Hello, Professor. Can you hear me?
Yeah, I can hear you. Yeah.
Thank you. Well, I'm specializing in robotics control. Well, actually, I don't know much about Python, but I can't wait to learn new knowledge. Thanks.
Thank you. Fiona Sharan.
Hi, Professor. Can you hear me?
Yeah, I can hear you. Yeah.
Okay. Hello, everybody. I'm Fiona. I'm from India. I finished my bachelor's in electronics. I'm here for my master's in robotics. And I already have quite a background in C++ and Java. And I'm interested to learn Python too. Thank you.
Thank you. Okay. You, Tijanian Lee. Hello. Yeah, go ahead, please. Hello. Hello. Can you hear me? Yizi Wu.
Hi, Professor. Can you hear me?
Yeah, I can hear you. Yeah.
Yeah, thank you, Professor. Hi, guys. I'm Izo Wu. You can call me Harry. So like I'm specialized in signal processing and communication. I just graduated from Northwestern Polytechnical University in Xi'an, China. So like I have already studied some Python in machine learning. So like I'm very happy to study with you guys. Thank you.
Thank you. Okay, Muniraj Sampath.
Hello, Professor. Am I audible?
Yeah, yeah.
Yeah, hi, Professor. This is Muniraj Sampath. So I'm from India. So I did my bachelor's in electrical and electronics engineering. So I'm in Western pursuing my power systems engineering. Yeah, thank you.
Thank you. Hui Lin.
Hi everyone, my name is Willie and I'm a MNG student of robotics. It's really nice meeting you guys. Thank you.
Thank you. Hao Tian Yang.
Hi, my name is Hao Tian Yang, and I'm a student of communication and signal processing. And I also took my undergraduate study at Western. So nice to meet you guys. Thank you.
Nice to meet you. Okay. Chuanyu Pu. Okay. Okay. Jilian Zhao.
Hi, my name is Xianglin, and I graduated from Ryerson University in electrical engineering, and I'm specialized in power system in Western University. Thanks.
Thank you. Ahmed Saad.
Yes, Professor.
Yeah.
Good afternoon, everyone. I am second semester here at Western. I'm specializing in power systems engineering. I look forward to working with you all, guys. Glad to meet you.
Thank you, Ahmed. Ben Shen.
Hi, Professor. Can you hear me?
Yeah, I can hear you. Go ahead.
All right. Hi, everyone. Hi, Professor. My name is Bing Shen, and I'm from China. I specialize in communication and signal processing. And just now, I heard Professor's very detailed introduction, and I think you must be a very responsible guy. And of course, I will also try my best to learn this course so that I can get more knowledge of the computer game, just like Python. Nice to meet you guys. Thank you.
Thank you. Thank you. Ling Tian Zhang.
Hi, Professor. I'm Lingtian Zhang, and you guys can also call me Lucas. I'm very looking forward to learning some Python because it will be very helpful machine learning and also other stuffs. And very glad to meet you guys. Thanks.
Thank you. Ahmed Abdeshafi.
Hello, Professor. My name is Ahmed Abdel Shafi. I'm an MNG student, my second semester in Power System Engineering. I'm looking forward for this course. Thank you.
Thank you. Josiah.
Hello, everyone. My name is Waregbe Josiah. I am from Nigeria and I am specializing in power system engineering, and I am looking forward to learning as much as I can. And yeah, thank you very much.
Thank you. Ping Bu Ju.
Hi, Professor, can you hear me?
Yeah, I can hear you.
Yeah, my name is Peng Bo Xu, and you can call me, and you can also call me Fanny's. And I'm majoring in the power systems engineering, and I'm really looking forward to learn some basic skills of Python because I think it's really convenient for me to tackle some problems. And I'm also looking forward to working with all of you together. Yeah, thank you. Nice to meet you.
Thank you. Heng Gong Ku. Heng Gong Ku, are you available? Hello. Okay. Jen Yu Ju, I don't know if I'm pronounced it correctly.
Hello.
Hello.
Hello. Yeah, you can hear me? Okay. So
Yeah.
my name is Xinyu Xu. It's hard to pronounce in English, I know, but yeah. So I'm specialized in communication and signal, and I completed my engineering bachelor degree in U of T. And I'm glad to meet you guys. And that's all.
Thank you. Week1-ECE9013.
Hello, Professor. Hello, everyone. My name is Renzi Chu. My specialization is in robotic, and I have learned C and C++ before. And I did my last project in Python, so I'm pretty looking forward into this course. Thank you.
Thank you. Jaslyn Singh.
Hello everyone, my name is Jasleen Singh and I'm from India. I am pursuing my master's in power systems engineering. Having this new course Python, it will be helpful for me in power systems engineering. Nice to contact with everyone.
Thank you. Linky Zhang. Linky Zhang.
Hi, Prof.
Yeah. Yeah, I can hear you.
My name is Link, graduate from Carleton, and I'm specializing in communication and signal. Very excited to take this course. Thank you.
Thank you. Jian John Hwang.
Yeah. Hello, everyone. My name is Jian Jun. My specialty is power system engineering. Hope to learn some programming skills in this course. Yeah. Thank you.
Thank you. Shinhan Yang.
Hi, can you hear me?
Yeah.
Yeah, hi. My name is Xinhan Yang, and I graduate from McMaster University, and my specialization is communication and signal processing. And nice to meet you guys, and hope we can make progress together.
Thank you. Mr. Akbar.
Hello, everyone. My name is Westi Agbe. You can call me West. I studied electrical and electronic engineering at the University of Greenwich in the UK. Then I have some experience in contracts. I was contracting the oil and gas industry, and now I am specializing in robotics. I have self-taught experience in Python. I'm looking forward to structured learning. Thank you very much.
Thank you. Eddie Kale.
Communities. You did not hear that word. Now you want to pamper those who have graduated that field.
It seems you have a problem with your mic, Eddie. We cannot hear you very well. Hello. Okay, thank you, AD. It seems you have a problem with your mic. Fatmir Mira.
Hello, Professor and everyone. My name is Mira, and I am the first semester in doing master engineering in power system. I don't have experience in Python language, so I'm very excited to learn and looking forward to have a good time with you. Thank you.
Thank you. Thank you. Yuan Chen Li.
Hi, Professor. I'm Yuan Xin Li, and I did my undergrad at Dalhousie University, and I'm specialized in communications and signal processing.
Thank you.
Nice to meet you guys.
Nice to meet you. Genwei Z.
Hi everyone, my name is Jimei and I'm from engineering medicine and the ECE department. I finished my undergraduate. I finished my bachelor degree last year at Western, and it's really good to be back to campus and nice to meet you guys. Thank you.
Thank you. Akshita.
Good evening, everyone. My name is Akshita. I'm from India, and I'm currently pursuing my master's in power systems engineering. I took this course because I've done online courses on Python, and I'd like to delve deeper into this course, and I'm actually glad to be a part of this family. Thank you.
Thank you. Robin Smith.
Hi, I'm Robin. I graduated from a master in robotics engineering or mechatronics engineering. This is actually my last semester here at Western in robotics masters. I took Python, but it's been a long time, so good to get a course to teach high level. Thank you.
Okay, thank you. Gi Wang or Ji Wang.
Oh, hi everyone. My name is Jiwon and you can call me Jessie. I graduated from Queen's University and I'm in MN robotics program. Nice to meet you guys.
Thank you. Sylvia Lu.
Hi everyone. I am Sylvia. I'm specializing in power systems and I took my undergraduate degree at Dalhousie University. Look forward to learning a lot from the course. Thank you.
Thank you. Muhammad.
Mohammed Sarmat.
Yep.
Yes. Hi everyone. This is Mohammed Sarmat. I'm doing masters in power system engineering and it's my last semester. I studied Python in the machine learning, so I am looking forward to enjoy this course and I will try my best to learn as much as I can. And thank you very much, Professor.
Thank you. Chia Foley.
What?
Chia Foley.
Hello, can you hear me?
Yeah.
Hi, Professor and your classmates. My name is Jeff Li. You can call me Jeff because that sounds close enough. My stream of study is robotic and control system, and this is my second semester, first year, also last year of study. And nice to meet you guys. Thank you.
Thank you. Okay. Jilan Zhao. No, I think you introduced yourself, right?
Yeah, I have introduced myself.
Okay. I don't know what's going on with my screen. Okay, guys, those who are remaining, please introduce yourself with your name. I don't know, my screen is not showing the other names.
Hi, Professor. I'm Yu Tianjian Li. When you called me several minutes ago, I have encountered technical problems, and the Zoom meeting is just a crash. So can I introduce myself right now?
Yeah, go ahead.
Okay. My name is Yu Tianjian Li, and you know the name is quite so the name is not easy to pronounce. So everyone can call me Jensen, Jenson. And I'm a student of robotics and control. This is my last semester at Western. I've used Python to get image information in real time as part of my undergraduate project. And another part of control logic written is in C. And the data from both languages is passed and subsequently processed through a one-way communication protocol that I wrote myself. So I have part of Python experience, and nice to meet you guys. Thank you.
Thank you. Thank you. Who else not introduce himself or herself?
Hello, Professor. Can you hear me?
Yeah.
Yeah, my name is Ho Han, and my specialization is signal processing and communications. Nice to meet you guys. I'm sorry I didn't turn my laptop's voice at that time.
Okay, no worries. Yeah. Okay, guys, who else?
Hello, Professor.
Hello.
Yes.
Yeah, go ahead.
Yes. My name is Aditi Kare. I have completed my bachelor's from India, and currently I am a robotics and control student at Western University. So this is my second semester, and I have some basic knowledge of C and C++. So looking forward to learn Python because yes, it is very important to learn Python. You can use it in many applications.
Sounds great. Thank you. Next, please.
Hello, everyone. Can you hear me?
Yeah, we can hear you. Go ahead, please.
Okay, I'm Shu Ning Lei, specializing in communication and signal processing. I'm looking forward to learn useful skills in this course, and nice to meet you all. Thank you.
Thank you. Thank you. Next, please.
Yeah, hi, Professor.
Hi.
My name is Vinit Puri. I'm pursuing Master of Engineering in Communication and Signal Processing, and I have some experience in Python. I'm looking forward to learn more from this course and working with you guys. Thank you.
Thank you. Next, guys. Is there anybody remaining, or everybody introduced themselves? Is there anybody else will go to introduce themselves? Okay. Would you like to have like 10 minutes break, or shall we continue? What do you prefer, guys?
Maybe in a bit, Professor.
What?
Let's continue, maybe in a bit.
Okay. So, can you see my screen now?
Yes.
Okay. So our course is ECE, as we told you that, as I told you before, that all most of the handout are from the original author of the book from MIT, and we do some minor changes to accommodate our needs in the course. So today we discuss the course outline. Then we'll go what is the computation, Python basics, mathematical operation, Python variable and types. Notes. As of next week, slides and code file will be uploaded to OWL before each class. I will do my best to upload it by Friday every week. So I'll put some examples of codes and the handout. Try to run it yourself to see the results, so it would be easier, smooth, and moving within our course. So highly encourage you to download them before the class, take notes, and run the code file when I run the files. Normally, I will use Jupyter Notebook to run all the codes. If you are not familiar with this, search YouTube how to install Jupyter and Python in your notebook and the Anaconda 3. This one for in-person courses. Bring computer to answer any class practice exercises. So each one will have his or her computer with him during the class. So if we need to run some codes or to have some any class practices, then you can run and will be with me in the same page. The course info, we discussed this. This is my email. My office is this one. However, I'm outside Canada, so you'll not find me. But if you need anything in person, we can meet via Zoom during the office hour by appointment, or you can meet with the TA, the course TA, in person. And if I'm in Canada, then we can arrange for a personal meeting. Okay, assessment. As we mentioned, we have 3 homeworks for 30%, midterm for 20%, quizzes, 2 quizzes for 20%, project proposal 5%, project report 15%, and the project presentation 10%. Activities, we mentioned this, that the project report and the presentation collaboration is allowed between the group members. However, your work should be genuine and original. And homework assignment, midterm test, quizzes, it should be individual. It should be individual. No collaboration is permitted. Important note, as I mentioned, all assignment, project, quizzes, and exam will be checked by Turnitin to confirm the originality of the work. We will be running a code similarity program in all delivered code, having a Turnitin report with high plagiarism. Oh, this is a typing mistake. I will correct it. Will cause an academic offense. University policy states that cheating is an academic offense. If you
Professor,
are cheat, yes.
The screen is frozen.
Shows the first page only.
Oh, really?
Yeah, we're only looking at the first page of the slide.
Okay. Okay, guys. Seems there's an issue with Zoom itself. Does it change now?
No.
No.
Yes,
I'm not sure what's going on. Okay, guys, I will quit the meeting and back in a few seconds.
Okay, thank you.
Okay, okay. Hello, guys. Can you hear me now?
Yes, Professor. Yes, Professor.
Yes,
Yeah.
Professor.
Okay, let me get the slides again. Can you see now the slide transition?
Yes, now, yeah. We
Okay.
can see more pages.
Yeah.
Okay. So this thing we discussed it before with the course outline. We were here. So this is plagiarism. So I will correct this and re-upload the handout. So each assignment or essay should be in your own word and should be original your work. Marking of a project requires all team members to participate in presenting the project via Zoom. Along with the OWL submission, you have to submit your presentation and your report via OWL. One group member will submit, and all group member names should be available there, so the mark could be assigned. For the presentation, the mark will be individual, and for the report, it will be group mark. Attendance is mandatory in the project presentations classes for all students with no exceptions, as I explained earlier. Now, what is programming? What is programming? Programming is problem solving. And you have to have the programming skills, knowledge of the concepts, and the problem solving mind. And on top of all of those is practice, practice, practice. How much you practice, how much you will gain programming skills, you will improve your problem solving skills. Also, your knowledge will be increased. So, Python language. The Python language was founded in 1991 by the developer Guido van Rossum. It is high-level language. As you may know, that we have 3 levels of programming languages. Low-level programming languages like machine language, which is zeros and ones. Intermediate programming languages such as assembly, and C is considered as they consider assembly as low-level language. However, some other scientists, they consider it as intermediate language. And also C is considered as intermediate languages because you can write assembly codes and high-level programming languages. So they consider it in between. And the high-level programming languages, which is English-like languages, such as Python, C++, Java, from the old one, what we have, Fortran, Pascal, those was used in 1990s. Dynamic programming languages, it's considered as dynamic programming languages. And if you are in a software engineering or a computer science, you will have a course called comparative programming languages, and then you'll know static programming, dynamic programming, what is the difference between those. But with our course, since it's an introductory, we just have to know that Python is a dynamic programming language. Focus in code readability. So one of the main or the amazing properties of Python, its focus is in the code readability. So the code is readable and easy to understand. Multiple programming paradigms are implemented within Python. Why Python? Why the university choose Python to teach it for students? Python has topped the charts in the recent years over other programming languages like C, C++, and Java. The programmers of big companies are using Python nowadays, especially with the machine learning and AI applications. Python is doing a great job with those areas. Interactive, interpreted, modular, dynamic, object-oriented, portable, high-level, extensible in C++ and C. So Python has a lot of amazing features that you cannot find them in the previous languages. However, most of my life I was using C++ and Java, but Python, it's the language of the current time. So anybody need to use or to develop any application, you have to use Python. Extensive support libraries, open source. So anybody can add library that everybody can benefit from these libraries in Python. Integration feature and improved programmer productivity. So if you have any idea, you can make your own library and add it to the language, and everybody can import that library and use it for their programs. So, course topics. In this course, we will learn programming principles, programming data structures, iteration and recursion as a computational metaphors. What do we mean by abstractions of a procedure and data types? Organize and modularize system using object classes and method. One of the amazing component, we'll talk it at that time of object-oriented, what we call it the modularity of code. You divide the code in simple pieces, and each piece will do certain job. This is one of the beauty thing of object-oriented programming, OOP. Well-known classes of algorithm, like searching and sorting algorithm, how do we implement them in Python? What the benefit of using these data structures? Then at the end, we will have a basic touch with the computational complexity and the complexity of algorithm, mainly the big O notation. What do you mean by big O notation? What does a computer do? Now, if I ask anyone of you now to move from your chair and go and close your door or your room door, or if it's closed, to open it, easy as a human, and we have brain to think, you will move from your chair, go direct to the door, and open or close it, depending on the situation of the door. But we have to keep in our mind that the computer is a machine. We have to instruct this machine to perform the job. So those who are in robotics and control, if you wanted to program a robot, if you give him an order, open door or a closed door, what to do? Can anyone answer? If you have an answer, just unmute your mic and go ahead.
If you tell to open or close the door, I think it does not enough information.
No, my question is, if you wanna program your robot to give him either one of those two instructions, open the door or close the door, what are the steps that you need to put in mind to program your robot to do these tasks?
Firstly, your robot would need to have a way to move, and it would need to have some sort of camera that can assess the environment and decide which object is a door.
Okay.
Then it would need to have some sort of motors that could move a piece, like an arm or such, a robotic arm, towards the handle and be able to grip it with just enough force to turn it and not break it. So there's many steps.
Yeah, amazing. From a computational point of view, as a programmer, how I will tackle this problem? The first thing, as your colleague mentioned, that the robot should has a camera to check the environment. The first point, the robot has to get the coordinates for himself, for the robot, what is his position in that room, and where is the direction that the robot has to move toward the door, and what is the distance. Then where is the handle? The door is closed, then I have to open. If the door is open, I have to close. All these steps, as your colleague mentioned, we have to take in consideration, and we have to put the program in the computer or in the robot. This to support my idea that to keep in mind always that the computer, the robot, any programmable object is a machine. So we have to translate all thing in our mind to a logical steps. Remember this term very well. Logical steps. So when we saying I have a program, what is the definition of a program or algorithm? Anybody has an idea how we can define the computer program? Simple definition.
Maybe a set of instructions we needs to provide the computer.
Yeah. Okay. So my definition to a program, since I was undergrad and always telling everybody, this is the program. What do we mean by a computer program? It is a set of logical steps that the machine has to execute, to arrive at the targeted solution. Again, it is a set of logical steps that the machine has to perform or execute to arrive at the solution. What do we mean by that? To open the door, I have to look around as a human. I have to look around, identify my position in the room, identify my situation. Do I lie down on the bed, sitting with a chair, on the ground, standing up, where I am in the room? What is the direction I have to move myself to go in the shortest distance with no obstacles on the way to the door? Where is the door handle? Is it a rounded handle? It is a normal handle or a classical handle that I just need to put it down, or it's a round handle that I need, is it locked, unlocked? All these logical steps, as a human, I do it by default because we have a brain to think. But the computer is a machine. We have to give all these, even you consider it trivial details, to be performed. Then at that time, I will arrive at the designated solution that I'm looking for. So is it clear what do we mean by a program, guys?
Yes.
Okay. Questions till now? Guys, if you have any question, don't hesitate. Either send me by chat or just unmute your mic and ask immediately. Don't let me move to the next topic without understanding the current topic. This is my way of teaching. Okay, so I'll give 1 minute. Do you have any question, guys? What do you mean by a program? What do you mean by logical steps? What do you mean by the basic definition of algorithm or program? Okay, I don't see anything in chat. Nobody raises their hand on the attendance list. Okay. Okay, what does a computer do? Fundamentally, the computer is literally doing computation, calculations. It is a big calculator. The first computer in the world is the calculator, which is defined by Charles Babbage, 1884, who we consider as the father of computer system. If you are interested, go and read about Charles Babbage. The first computer in the world, who can tell me what is the first computer that the human ever used? Can anybody tell me?
It's ENIAC, like from Pennsylvania. I remember.
What is it?
ENIAC from Pennsylvania. I think it's founded in Pennsylvania University. Sorry. Can you hear me?
Yeah, I can hear you.
Yeah.
This is the first computer that a human use.
Oh, you mean that? Oh, okay.
The abacus, which is the first calculator or the first computation machine that the human use. It is aged now more than, I believe, 3,000 years. I believe that. It's called the abacus. So this is the first computing machine that human ever used in the life. So this is the first one. So fundamentally, the computer is doing calculations, 1 billion of calculation per second nowadays. Remember results by the fact that nowadays computer has a memory, hundreds of gigabytes of storage nowadays. I remember when I was first undergrad in 1995, we used at that year, we start using the floppy disk, 3.5 inches of floppy disk. Anybody saw the floppy disk before?
Yes.
Yes, Professor.
Yeah,
Yes.
with a maximum capacity of 1.44 megabyte, and it was wow at that time. 1.4 megabyte, and we have a computer with 100 megahertz speed called Pentium 1 in 1996, and it has a 1.2 gigabyte hard disk. Oh, wow. And 2x CD-ROM. It was, guys, a big movement from 1995 before and after. So at that time, my first PC was Pentium 100 with 4 megabyte of RAM and 1.2 gigabyte hard disk. It was one of the top. And how much it was, this device? For almost 4,000 Canadian that time. It's a PC, not a laptop. Any laptop, you are talking about 10,000 Canadian and above. So we are talking about 25 years, 26 years. You see how much it's become cheap. And even my professor that time was talking about the computer in 1980s and 70s. They said, oh, now it's very cheap and very fast. And one day, once you are instructor, you will told your student at that time we use Core i7 11th generation with 8 cores, and you laugh at that time. We don't know how many cores at that time you will have. So this technology is moving very quick. But our book is considering the new generation of computers. What kind of calculation? We have two types of calculation. The one is built in within the computer, and the one you define using programming languages and codes. So again, to take this level of abstraction that the computer is machine. So computers only know what you tell them. What you tell them. They cannot do something from nothing. Even in machine learning and AI, we have a training phase. Right? Those who took machine learning. With artificial intelligence, at the beginning, we have to define training set. We train the computer to recognize patterns. Then the computer starts using what we call artificial intelligence to predict or to estimate or to classify or whatever. So the computer is machine. Same as a car you are driving. Wherever you direct it, how much you press the throttle, you press the brake, it will follow your instruction. So a computer is a machine, like a car, like a bicycle, like a motorbike. How you drive it, how it will give you the result. Types of knowledge. We have declarative knowledge, which is a statement of facts. Someone will win a Google cardboard before a class ends. These are facts. Or imperative knowledge is a recipe or how to. For example, student signups for raffle. Anna open her IDE. Anna chooses a random number between first and nth responder. Anna finds the number in the responder's sheet, who is the winner. So the fact we know, if we are in a class and there is a present like a Google or whatever, or a Google cardboard. So somebody, the fact that we know that one of the class members will win this Google cardboard before the class ends. But the imperative knowledge, which is the recipe or how to, how we will know who will win the Google cardboard. So the student will sign up, then Anna opens her IDE, then she will choose a random number. This random number is associated with certain student, and then we will announce that student number 17, for example, is the winner. Who's 17X? Then we announce X as the winner of the Google cardboard. So we have facts and we have imperative knowledge. The imperative knowledge is how to, and this is the programming. We have to instruct the computer how to arrive or show us the result. Clear, guys? Now let's have a numerical example to make our example easier and more computationally, rather than an example who is the winner of the Google cardboard. If I ask you to find the square root of a number X, and you said me, let's assume that the number is X and the square root is Y. such that y times y equal x. This is a simple mathematical definition of the square root, right? Okay, what is the recipe or the imperative knowledge that we are going to do as a human? So, for example, if we assume that the number x is 16, so what is the square root of 16? So at the beginning, we will start with a guess g. And if g times g close enough to x, stop and say g is the answer. How much is the close enough? This should be clear in the question. As your colleague now, close the door, there is no enough information in this question. So the question should be clear. How much close enough to first decimal point, second decimal point, third decimal point, depends on the teacher or the person who asked this question. So other way, based on the number that we receive, we'll make to reduce or increase the first guessed number in order to be closer to the right answer. So otherwise, make a new guess by averaging g and x over g. Using the new guess, repeat the process until close enough. For example, the first guess, I said 3 is the square root of 16. Okay, g times g, to make sure or to test our assumption, it's 9. 16 times 3, it's 4.17. Oh, no, this is far away a bit. Okay, then we guess another number. Since we are below the 16 by g, g times g, then we choose 4.17. So the answer is 17.36. X over g is 3.837, and g plus x over g divided by 2, which is 4.0035. And based on the instruction, this is still far a bit from the required answer. 17 is a way more than 16. Okay. Assume that the questions say find the square root, and your assumption should put us at least 3 decimal place plus or minus from the number 16. So then this is higher, so we will deduct a bit and we choose 4.0035, and it gives us 16.0277, which is almost the near. X over g is 3.997, which is 4.0005 times 2. So this is the nearest guess. Then we will say the square root is 4 by our guess. Clear, guys, the example? This is, we call it finding the square root by guessing. We try to simulate an example of picking a random number with the Google Cardboard gift. Okay. What is a recipe? Sequence of simple steps. Recipe is a sequence of single steps or simple steps, and it has a flow of control. From one step I move to another. I might repeat some other previous steps, then till I arrive to the solution. A means of determining when to stop. We should have a clear information that telling us once you arrive at that point, stop. So there is no open-ended program. No open-ended program. And next week, when we talk about iteration, there is a fatal mistake if we are entering an infinite loop that we keep circling and the computer will not stop. So there should be a stop condition. I have to stop at certain point. So I have a question for you guys. Is 1 + 2 + 3 equal algorithm? Yes or no?
I think it's no, because there is no result.
No, if I write a program to find the sum of 1, 2, and 3, can I call this algorithm?
Yes.
No,
Yes.
Yes. So to write a program to make a summation of 3 numbers, I need an algorithm. What is an algorithm again? It's a set of logical steps, same as the definition of recipe. It's a set of logical steps that the computer has to perform, or the computational machine, to be more generic. The computational machine has to perform to arrive at the solution and to have a clear output. Computers are machine again. How to capture a recipe in a mechanical process? Those who are in engine medicine, you have a lot of mechanical courses, right? Especially the medical devices. Those on robot also need a lot of mechanical knowledge, or a mechatronics if you are doing like a hand or leg for those disabled people. So there is a mechanical process with those devices, right? So how to capture a recipe in a mechanical process? Fix the program, computer or calculator, store the program, computer, machine stores and execute instructions. Then you have to put your recipe, put it in a program, then inject this program to the controller or the on that circuit that you are using. I'll not go specific like LSI or PSI or to the controller. You have to inject your code so the device or the mechanical process could be run even in a manufacturer or on a medical device or whatever. So I have a fixed program in the computer, or I have to get a stored program to inject it to a certain computational device, like a robot, like a machine, like a toy, whatever. And this device or this object, a toy or a device in a manufacturer or a production line or whatever, will execute this program, which is stored in one of the control units that controlling the machine or that object. So the simplest machine or computing machine architecture are consisted of this one. What we call it, guys? These both units, what we call them?
CPU.
Central processing unit.
Yes, CPU, central processing unit. It consists of 2 main units, which is the control unit, the program counter, arithmetic and logic unit, do primitive operations, and we have the registry and all of other things, but we'll talk in the simplest way. And those are connected to the computer memory, and from the other side they are connecting with the input and output devices. So this is the simplest computation machine architecture. CPU, which consists of control unit, arithmetic and logic unit, and those are connected bidirectional with the memory, and also connected in one direction with the input unit, and the other direction will be go to the output unit. Clear? Questions? Questions? Okay. Store the program computer, a sequence of instructions stored inside the computer built from a predefined set of primitive instruction. Arithmetic and logical operation, simple tests, moving data from one place to another place, from memory to hard disk to USB to screen. So we are moving data. Special program, we call it interpreter, executes each instructions in order. So guys, to make the thing simple in this slide, we have two types of high-level languages. Either a programming languages that use a compiler, or a programming languages that using interpreter. We call it interpreter, not a compiler. What is the difference? The compiler will take the whole program as one unit, execute it step by step, and if there is error, it will give it to you as an error report, and it will not run the program. Interpreter is trying to translate each line of code at the time to make sure it's correct or not, and if there is an error on that line, it will give it to you immediately. So interpreter is going with the program line by line. Where the first error is, it will give it to you. This is error. You have to correct it, then it will complete to the next line. The compiler will take the program as whole object, then it will try to execute it. If there is any error, it will be reported, otherwise it will be executed. Clear? What is the difference between interpreter and a compiler? So the interpreter use this to change flow of control through sequence, stop when done. What do you mean by basic primitives? Turing showed that you can compute anything using 6 primitives. Those: arithmetics and logic, simple test, moving data. Modern programming languages have more convenient set of primitives, such as Python, which has a law, can abstract method to create new primitives. Anything computable in one language is computable in any other programming languages. What is the difference? It could be easier in Python. I have to write 3 lines of code. However, in C++, I need to write 20 lines of code. But if it's computable here, it will be computable there. So anything computable in one language is computable in any other programming languages. Clear? How do we create recipes? A programming language provides a set of primitive operations. Expressions are complex but legal combination of a primitive in programming languages. So I can say a plus b, or I can make it an expression, a plus b to the power 2 divided by d times x. Then I can make it arithmetic expression, for example. Expression and computations have values and meaning in programming languages. Any expression should have a value. Any computation process should have a value. Aspects of languages. Primitive constructs. It is English-like word, we call it. English-like words. Programming languages, it's numbers, string, simple operators. We will be introduced to float, Boolean, whatever. So each programming language has what we call it a syntax. What is a syntax? It's the grammar of that languages, how I write a correct line of code. Each arithmetic expression, logical expression, text, printing, input, output, I should follow the grammar of that language.
Excuse me, Master, sorry to interrupt you. Are we still on page 20 or we already moved on because the screen is still probably frozen because we're still looking at page 20.
Oh, we are on page 24.
Oh, the screen, I think the screen is frozen again, and yeah.
So can you see now?
No, I'm
Okay.
still looking at page 20.
Okay, okay, just give me a second.
Okay, thank you.
Can you see my screen now?
Still number 20.
Yeah, we are at 20. Okay. Now 21, you can see?
Yes. Yes, yes, Professor.
Okay, I understand what's going on because we are recording the class. So the size of video, I think it's become a massive. That's why Zoom keep frozen. So as of next week, what we will do, every 50 minutes, we will have a break, 5 minutes break. Then we will rejoin the class and save it again, or make it 3 parts each class, okay?
Okay.
Okay, so we're talking about what do we mean by expression. Each expression should has a value. Here, that's the programming languages is English words, but it should have a syntax. What do we mean by syntax? It's the grammar of the programming languages. For example, if I have this words in English, cat, dog, boy, is it as a synthetic? Does it have meaning as a sentence? In the syntax? No. But if we said cat hugs boy, grammarly it is correct, or as a kind of syntax. It is a correct sentence grammarly, but it doesn't have a meaning. In the programming languages, if I write between double quotes high, then 5, it's not valid. But if I wrote 3.2 times 5, this is valid. And the programming languages will understand. And as you may know, all of you, that the star means the X in mathematics, which is times. Still you see the new screen, the 25?
Yes.
Okay. Now, static semantics. What do you mean by static semantics? In which syntactically valid string have a meaning. Here we said it's grammatically correct, but no meaning. Here, I are hungry. I are hungry, syntactically valid, but static semantic error. Doesn't have a meaningful meaning of that sentence. In the programming languages, when I say 3.2 times 5, it's valid. But if I said the 3 plus high, it's a static semantic error. So what do we mean by these slides? That we have to follow the correct grammar and the correct syntax of any line of code that we will write in our programs. What do you mean by semantics? It is the meaning associated with a syntactical correct string of symbol with no static semantic error. In English, can have many meanings. Flying planes can be dangerous. This is a fully grammatically correct and a meaningful, or what we call it semantic in computer or in programming, it's correct. Programming languages have only one meaning, but may not be what programmer intend. So it's a good habit, and always I'm encouraging all my students, when you write your code, try to use a comment. I will teach you how to use a comment in Python to clarify what you are trying here to do. Okay, what if we have syntactic errors? It's common and easily caught by the compiler. Static semantic errors, some languages check for these before running a program, can cause unpredictable behavior. Sometimes you can write grammatically or syntactically a correct program. However, the result could be a catastrophe. So we have to make sure that we write the right code and getting the right result. No semantic error, but different meaning than what programmer intend. So at that time, you will have a result, but not the one you are looking for. Sometimes if I go in an infinite loop, then the program crash, stop running, program runs forever, program gives an answer, but different than expected. These are what we call it semantic errors. The code I wrote is correct, but it's not written in a correct way that will arrive me at the designated answer or at the objective of the program. A program is a sequence of definitions and commands. Definitions evaluated, command executed by Python interpreter in a shell. So with Jupyter, we are dealing in interpreter way. It will give me an error in each line I wrote. Can be typed directly in a shell or stored in a file that is read into a shell and evaluated. Now, next week, we will start with the problem set 0. We'll introduce you to these Anaconda. But guys, I hope that all of you next week, you have Anaconda 3 in your notebook. I'll try to find like a manual on how to do this. So we'll be on the same page by next week. I'll try by today, by Thursday. Tomorrow and Wednesday, I'm extremely busy. So I'll try to send you something by Thursday. Objects. What do you mean by object? We said that Python is an object-oriented programming language. What do you mean by object? It is the minimum abstraction level in these languages. What I want you to just memorize for this time, that object, each object has a type and we could add some code to be executed within that object. This concept, we call it encapsulation in object orientation. We will discuss this further once we reach to object oriented. But once we mean an object, each object has have a type, or object have a type that defines the kind of things or a program can do to them. For example, Anna is a human, so she can walk, speak English, etc. Then if we have a walkie, so he can walk also. She can do moi, etc. Object scalar cannot be subdivided. Non-scalar for these objects have internal structure that can be accessed. And this is what I mean, that we have the definition or the type and some associated code with it within the same object body, and we call this concept encapsulation. We encapsulate the data types and the code together. And this is one of the most characteristics of object orientation. Let's start with scalar objects and with the numeric types. We have integer in Python, which represent an integer number, as we know in math, with no decimal points or floating point. And that number, for example, 5, 11,000, 1 million. Float represent a real numbers, what we call it a real numbers in mathematics. And those are who has decimal point or floating point, we call it in computational. The floating point, for example, 3.27, 3.14, like pi value. 3.0 is a float number, while 3 itself is an integer number. Non-type. Python introduced something more flexible. You cannot see these in some other programming languages, not all of them. Some of them they have, which is the non-type object, which is a special object and has no value, none. We can use the word type between brackets to know if I have an object in the program and I don't know what is the type of this object, then I can write type I, for example, the object name is I, then it will give me like type 5, it's integer, type 3.0, it's a float. But if I wrote here type 3, it will give me integer. Okay, can we convert types? Yes, the answer is yes. Can convert object of one type to another? Yes. Float 3, it will give me the answer as 3.0. Integer 3.9, it will truncate all decimal point and give me only the integer number, which is a 3. It will not round it. Rounding is different instruction to the program. So if I write just int and any number, it will take the integer part of the number and truncate all other, the decimal point and whatever after the decimal point. Clear, guy? So integer of 3.99999 is a 3. Clear? Questions?
Yes.
Printing to console. For example, if we have this one and we write 3 plus 2, it will give me 5 in Python. If I wrote a print 3 plus 2, also it will give me 5, which is the same command. Expressions combine objects and operators. Once we combining objects and operators, then we call it an expression. So each expression should have a value, and this value has a type. could be integer, float, string, whatever. Syntax of a simple expression, which is object, operator, object. I plus j is an expression, and we are looking for the sum. I minus j, which is the difference, subtraction. I times j, which is the product of multiplication. I slash j, which means the division. If both are integer, result is integer. If either both are floats, the result is a float. For division, the result has the float type. Whatever, even if I divide 4 by 2. Once we have a division, Python is designed to have any result object of a type float once we are using the division. But for plus, minus, multiply, if we're dealing with integer, the object will be integer. If we're dealing with a float, the object will be float. But with the division, it's always a float. Clear? Questions?
Dear Professor, I have a question.
Yeah.
So for I and j, we have to declare that it's an integer or the float, or the Python will execute automatically.
Yeah, if I define I as integer and j as integer, then automatically Python will put the sum as integer.
Okay.
If I have I as integer and j as a float, Python will make the answer is a float by default. So it depends how I define I and j. But only in the division, whatever I define them, Python will choose the answer to be from the float type.
Okay.
Clear?
Yeah, clear.
Questions? Who can tell me what is this? It's the same in C++ and Java.
It's a mod.
Yes, it's the modular, yeah. So I mod j, the answer would be the remainder when I is divided by j. For example, if I say 5 modular 2, what is the answer, guys?
1.
1.
1.
Okay. If I wrote in Python star star, which is multiplication, multiplication, what does that mean?
Raised to the power.
It's the power. Those who are familiar with C++, we will use the shift and the number 6, right? To define the power. But here in Python, because once you introduce yourself, a lot of you have experience with C and C++. So the power in Python is the star star. However, in C++, it's the linked list or pointer to pointer, right? Those who are familiar with C and C++, if I wrote star star that, before the object, that means I'm dealing with linked list with dynamic memory allocation. But here, let's concentrate on Python. Don't be confused between different languages. If you have an experience with other programming languages. So when I said I star star, that means I to the power I to the power j, sorry. So if I equal 2 and j equal 3, that means 2 to the power 3. What is the answer would be?
8.
8. Clear, guys? Those are the basic mathematical operation with Python. Plus, minus, star, multiply, slash for division, percentage for modular, star star for the power. Clear? So those are the simple operations. Now, this slide, we are talking about the priority of mathematical operation in a mathematical expression. What does that mean? What will be executed first? The highest priority is for parentheses. If I put parentheses, those would be executed first. I'm telling Python start here. Then the second highest would be the power, then the multiplication and division. They have almost the same, then a plus and minus executed left to right as appear in the expression. I will have in for the revision before the exam, I have a tablet that I can write on it notes. So we'll do a lot of examples about the priority of operations on that time. But also next class, we'll do some using the Jupyter to have a live examples on Python. Binding variables and value. What do you mean by binding? Equal sign is an assignment statement. Once we have an equal sign, we call it assignment statement of a value to a variable name. When I say pi, it's a variable. The value is a 3.14. So I'm assigning the value of 3.14 to a variable. I name it pi. So this pi underscore approximation is of the 22/7, and we know this in math when we count anything related to circle area and when we deal with shape areas or circular shapes, we use pi. This value will be stored in the computer memory, and assignment binds the name to value. When I'm saying print pi, it will print 3.14. Retrieve value associated with the name or variable by invoking the name by typing pi. Whenever I type pi, it will give me the 31.4159. If I use it in an expression in the name of pi, it will be replaced with the value, with the associated value in the memory location that we name it pi. Abstracting expression. Why give name to values of expression? The answer, to reuse them instead of values. I don't need to remember the value each time. I assign a value for the variable, and I can use that variable name anytime I need to use it. Easier to change code later. Pi, radius, area, pi by radius times 2 to the power 2. And everybody know that the area of circle is pi r squared, whereas r is the radius, right? So here how we do the area of circle using Python. We will apply all of these codes next class, guys. But I want to make sure that everybody has Anaconda and has Python and Jupyter. Programming versus math. In programming, you do not solve for x. Pi equal radius equal 2.2, area of a circle. This is a comment. So here I'm saying that the following line of code will find the area of a circle. Area equal pi radius square, radius equal radius plus 1. An assignment expression on the right evaluated to a value. This is the first line. Variable name on the left, radius, and we give it a variable value. Equivalent expression radius equal radius plus 1. Is radius plus equal 1? Is this a statement? Radius equal radius plus 1. Is it the same as this one? Radius plus equal 1. In C++, yes. In Python, we will test it next class. Those who has experience with Python, what is the answer? Yes or no? Is radius equal radius plus 1? Is it the same as radius plus equal 1?
Yes.
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 Same as C++ and Java, but we will do it practically next class. Our last slide. Changing bindings. What do we mean by this? Can rebind variable name using a new assignment statement. Previous value may still stored in memory, but lost the handle for it. Value for the area does not change until you tell the computer to do the calculation again. Pi equal 3.14, radius 2.2, area, which is pi r square or radius square, radius equal radius plus 1. But does this will calculate the new area after we are increasing the radius by 1? With this line of codes, do we will get the new area?
No.
If we call the area again with the new radius value, does it will give us the same area as before when the radius was 2.2? No, because we rebind the value of radius with the new one. So pi still 3.14, no change. The radius changed from 2.2 to 3.2. But if I write area, it will always giving me the area with 2.2. If I said area again after this line equal pi radius times 2, then the area will have the new value with the new radius, and the old radius area will not be appear. Is that clear, guys?
Yes, Professor.
Okay. Questions? We are done with today's class.
Professor, could you
Normally,
please
my
go
classes
to...
will not take that long. Sorry to interrupt you. My classes will not take that long. Our classes will be almost 2 hours plus, with the break in between. But today, because we introduce ourselves, we discuss the course outlines, each student introduce himself. Maybe the next few classes will take less than this time. It will be 2 hours plus till we finalize the group project and the group list and the name of the project, the title of your project, till we arrange ourselves. Then the remaining will not exceed 2 hours as teaching. With the break, it will be 2 hours 15 minutes. I don't like to, because I know 3 hours a class, especially in the night, it's too heavy. So see you next week.
Professor, could you please move to page number 35?
Page number 35. Okay.
Yeah, here isn't like Python, does it follow BODMAS rules? So if it follows BODMAS rule, division should come before multiplication, right?
What
Like
is it?
the order of, like does Python follow BODMAS rule, like bracket, order, division, multiplication, addition, subtraction?
Yeah, so it will take the brackets first, then the power, then the multiplication and division at the same range, then the plus and minus as
But
the
then
lowest priority.
but then in BODMAS rule, division comes before multiplication, right? Like because I've learned that these programming languages, they follow BODMAS rule. So that's why I just cross-verifying.
No, it's never that division become before multiplication. They
Okay.
have the same in C++ and Java, they have the same. And also here.
Okay.
Yeah.
Okay, perfect.
So
Thank you.
next week, we'll do a lot of example on this. So it will be clear for you.
Okay, Professor. Thank you.
Okay, you are welcome.
Hi, Professor.
Hi.
Hi. For the last page, like you said, like previous value may still be stored in memory but lost the handle for it. But if we want to recall the previous value, how do we do that? Like for the radius, like the previous value is 2.2, and in the final like statement, the radius plus 1. But how could we, if we want to use the previous value, how could we recall that?
Okay, then you have to change the radius back to the original value. This is, we call it rebind.
Yeah. Sorry.
So then
here,
for example, you find the area here, then you wanna back to the original value of the radius. Then you will set radius equal radius minus 1, or you can set radius equal 2.2.
Yeah, all right, I get you. But if we already did like in the loop something, not in the loop, like the radius plus allowed 1, like a plus 1 for multiple times, but we still want the first number, like because for example, like the radius plus until like 10.2 something, but we want the first number. How can we recall that? We just change the statement to the first number, right?
Yeah.
Or there's another way.
The statement to the first number, or you can save the original radius value.
All right.
Radius
so just
0,
store the original value in the
equal 2.2, then radius equal radius 0 plus 1, and then you can change the radius and you keep the radius 0, the original value. If I need the original value, normally the good practice is to have it saved in a separate assignment statement, so I can back to it whenever I need.
All right. Got you. Thank you.
You are welcome. Later on, when we talk about functions and procedures, I'm not sure if I will touch this one with the handout, with the syllabus, but we used to have call by value and call by reference in other programming languages. I will see if I touch a base with the example about those. So you can have the same variable with two names, once inside the function and once in the general program. So any one change, you will see the change on that component of the program, not in the other. So just be patient. Let's go step by step, because some students, they don't have like enough experience in programming. So I will consider or will deal with all people in this class as beginners. Even some of you has a good experience with machine learning and advanced programming in Python, but I have to go with the majority of the class as introductory course. Any other question, guys?
Excuse me, Dr. Muhammad.
Yes.
Are there any lab tutorial for this class?
Yeah, I talk about this. We have a programming or in class practices, and we will start using them by next week.
Okay,
But I want to make sure that all students, they are installing Anaconda and Jupyter, Python Jupyters in their laptops. So once we start applying a code, they also can apply in their machine.
Yeah, but it should be it should be by using their laptops, but not in the university lab. I mean, in person.
This is a full remote learning course, Aisha.
Oh, okay. Yeah, I thought for lab it's.
No. I said if the department said that the midterm should be in person, I designed the course to be fully online and they approve it. But if there is like we enforce to have something in person, the TA will manage that. But you know, it's a graduate course, so there is no tutorial assigned to graduate courses.
Okay, thank you so much. Thank you.
Any other questions, guys?
Yeah, Professor. For the project, are we gonna be allotted the topics, or we need to decide it ourselves?
No, for the project, I'm let's say I'm open if the group suggests their project title. Once they put their proposal, if their proposal is approved, then we can go. If it's not, this will be go with the TA. There's a process before you submitting the project proposal. So the project title, you send your project title and a small paragraph about it. Then if we need the change or to add some more features or whatever, we will be discussed with each group individually. But we are up, so we will open the floor for you to suggest the topic. We'll give you some guidelines. Since your project align with those guidelines, we are okay to choose you will pick up your project title, not me. Clear?
Okay, thank you, Professor.
You are welcome. Any other questions, guys? Okay, you are free to leave. Nice to meet you and see you next week.
Thank you.
Have a great evening.
Professor.
Thank you.
Thank you, Professor.
Thank you,
Professor.
guys. Have a great evening.
Thank you, Professor.
Thank you.
Okay, Professor.
Yes.
So you said we should install the Jupyter, but I know there are many compiler of the Python. So can I choose the compiler that I used before or I like? Like
you can use any version of Anaconda and any version of Jupyter.
No. I think I used to. I'm now using the JetBrains and JetBrains as my Python compiler. So can I keep it during the class or?
Yeah. You can use any platform you like. I will
okay.
use Jupyter and Anaconda 3. So if you want to use the same as mine, or you want to keep your own, it's up to you. All are Python.
Okay. However, there is a problem that the different platforms have the different format or the project format. So there will and we have a group project with the code in the last. So is there we should choose to transform to the specific platform that make sure you can open it.
if there is a difference in the syntax, you have to follow our book syntax. So we use the generic Python syntax.
Okay.
So if the one you are using is different a bit, so with your group, you have to agree with each other which platform you will use.
Okay, thank you.
You are welcome.